welcome to another Walking Talking mock for further maths. This is the 2016 paper 2 and let's get started. So a triangle has these vertices. Work out the area of the triangle ABC. You may use the grid to help you. Well, thank you. I'm definitely going to use the grid because I would have drawn a sketch anyway, even if they hadn't given me the grid. Minus 4, 3. Oh, my ruler is downstairs. Well, this is rubbish. Okay, close enough. Okay. Now working out the area of this triangle, I'm going to use this tip that I got. Who told me this? I think Ayub told me this, but he was taught it by Miss Spencer, who was doing a revision thingy, which is to turn it into a square, and then just by adding these right angle triangles, and then you can just work out the area of the right angle triangles, which are easy because half base times height, and then take away from the rectangle. Did I say square? I meant rectangle. Okay, so the area of, let's call this one A, let's call this one B. The area of A is going to be minus 42, so that's 6, so half times 6 times 2, which is going to be 6. And the area of B is going to be half times 3 times 6, which is going to be 9. The area of the rectangle is going to be 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, which is 30. So the area of the triangle ABC will be 30 minus 6 minus 9, which is 15. I just realised there's such an easier way of doing that. Because yeah, this triangle is a dodgy triangle, but at least it is like flat on one side, if that makes sense, you know. The height and the base are perpendicular, so I could have just done half times base times height, and that would have given me 15 as well. But oh well, not wasted too much time. Okay, so we've got a function which is quadratic, has a domain from -1 to 5, and write down the equation of the line of symmetry. That's easy, it's here, isn't it? So x equals 2. Use the graph to work out the solutions to, is that the same equation? Yeah, it's the same equation, but this one equals 5. So I just need to go to 5. So that's minus, one decimal place, 0.8. Right, x equals, and, well, or I guess, x equals, well, or and, it doesn't make a difference. What's that? 4.7, no, 4.8. You know, the good thing about this is then you've got your calculator, so you can actually check, like, is that correct? So that squared minus 4 times that plus 1 equals 4.84, which is not 5, but it's close. Okay, and then if I put 4.8 in there, and do that squared minus 4 times that plus 1, 4.8, yeah, so close enough. And and then write down the range of f of x. Okay, so let's have a look. The range of this, well, the highest value is 6, the lowest value is -3, so f of x is between -3 and 6. And I'm going to put equals here and here because they had equals here and here, so it's going to match. Okay, L is a straight line with this equation. Which point does L intersect the x-axis? Let me rearrange this to make y equals mx plus c. So I'm going to take away the ax, and I'm going to divide by b. Okay, so where does it intersect the x-axis? Well, it intersects the x-axis when y is 0. It's probably going to be easier to use this version actually. If y is 0, that's going to disappear and you end up with ax equals c, which means that x will equal c over a. So that one. And then what is the gradient of a line parallel to L? The gradient is minus a over b. So there we go, minus a over b. Work out the point of intersection of those two lines. Okay, so simultaneous equations. I think I'm going to make that one look like that one. So I'm going to add 3x to both sides. Okay, and now I'm going to use elimination. Let's make the y's the same. So I need to times this one by 2, and I need to times this one by 3. So 4x plus 6y equals 22, and 6x plus 6y equals 39. Right, I need to take these away because I need to do 6y, take away 6y to cancel them out. Can I just pretend these are upside down? Okay, so I'm actually going to do this one, take away that one. 2x equals 17. Well, that's not the nicest answer ever, but okay. And then y is going to equal, 2y equals 13 minus 3 lots of that. So 3 times 17 over 2, 13, take away that, and then divide it by 2, minus 25 over 4. They're kind of ugly answers, so I would double check those. Well, in fact, I can double check them very easily by putting them into this equation and see if it works. Plus 3 times, I have a feeling this does not work. That doesn't even almost work. What did I do wrong? I times this by 2. I times it. See, this is why you check your answers. Okay, let's try again. Okay, let's try this. So 2 lots of 17 over 5 plus 3 lots of 7 over 5 equals 11. Okay, good, it works. Because it doesn't say solve this, it says work out the point of intersection. You need to write these as coordinates. Oh, that's fine, it tells you, it makes it clear there anyway. So there's no way you're going to screw that up. There we go. Ooh, I like this kind of question. I love thinking about always, sometimes, never in maths. It's always an interesting thing to think about. Okay, so A is negative, B is bigger than 1, C is between -1 and 1. Okay, is A cubed going to be less than 0? Yes. If you cube a negative, you get a negative. I'm confident that that is always true. Okay, is B less than 10A squared? Right. A squared, all we know about it is that it's going to be positive. Okay, 10 times a positive number. Is B going to be less than that? It might not be. Because, for example, B could equal 1,000,000. And A could equal -1. And that's going to make 10, and that's going to make 1,000,000. So that's it could sometimes be true though, because I could have B equals 2, and I could have A equals -1, and that's going to be 10 is greater than 2. So yeah, sometimes it's true. Okay, A times B is positive. A is negative. B is positive. No, that's not true. If we times them together, it's going to make a negative. So that's never true. And then B take away C is bigger than 1. Let's see. Let's say C was 0 to start with, and B was 2. 2 take away 0 is bigger than 1. Okay, that's true. If C was, okay, it can't be 1, but let's say C was 0.9 and B was 1.1. B take away C is bigger than 1? No, it's not. It's not. So that's sometimes true. Okay, for this curve, dy by dx equals that. Oh, this is very similar to that question that was on paper 1, isn't it? So yeah, we should have done this paper before, but it's paper 2, so I only did paper 1s before the paper 1 exam. When x is minus, okay, so let's put -2 in. It says the gradient is 12. Okay, so -3 minus 16k plus k equals 12. So minus 15k equals 15. So k is -1. Simplify fully. Wasn't this question also on paper 1? I don't know. So I need to do 2/3 cubed, so that's 8/27. I need to do x cubed, which is x to the power of 9, and then I've got y cubed. I wouldn't say that that's simplifying it. I would say it's, I don't know, evaluated? No, I don't know. Number 8. Okay. Luckily, this one does not say use an algebraic method. So if I put d here, -6, 4, and then a -2, 9, that's going to be up here. And then p is somewhere on here, so that d to p is 3, and p to e is 5. Okay. So, let's see. This whole step is 4, and the whole rise is 5. So I need 3/8 of 4 across, and I need 3/8 of 5 up. So 3/8 of 4 is 1.5, and 3/8 of 5 is 15/8. Okay, I could have done that without a calculator. So from D I need to do -6 to that, so that's -4.5 would be the x coordinate, and then from 4 up by that, so that's 5 7/8. PQ is parallel to BC. Prove that x equals 3y. Okay. That's going to be 180 minus x. Let me write that down. PBC equals 180 minus x, because supplementary angles add up to 180, and then I can say y plus 100 plus 2y plus 80 plus 180 minus x equals 360, because angles around a point add up to 360. So that means 3y plus 360 minus x equals 360. So 3y minus x equals 0. So 3y equals x. Proved. That's a nice little question. Simplify this. Okay, let's factorize. Don't get this the wrong way around this time. -5 minus 2. And 5 and 3. So I want -5 plus 3. Okay, cancel, cancel. So it's x minus 2 over x plus 3. Factorise fully. Okay, what's the common factors? We've got some w's, 2 of those. We've got 3 x's, and we've got 2 y's. And then what's left? We've got 3 w's left here. We've got no x's, no y's. And here I've got no w's, 3 x's, and 1 y. So that. The x squared term in the expansion of that was on paper 1 as well, wasn't it? Do you remember? It was very similar to that. We really should have done this paper before paper 1. But, I mean, how did we know? We didn't know. So, 3x cubed plus 3px squared plus 15x plus 4x squared plus p4x, should have put 4p, oh well, plus 20. And it says the x squared bit, so that bit and that bit, so 3p plus 4 must equal minus 23. So 3p must equal minus 27, so p must be minus 9. Here are the first 4 terms of linear sequences x and y and a quadratic sequence z. Look at the nth term of sequence x. Is this going to go on? Okay. It's going up in 2s, and it doesn't start from 2, it starts from 7, so it's plus 5. Oh, look at this massive space. This is going to be a hard one. Oh, do they give you space on the back? No, they don't. It's only 3 marks though. The nth term of sequence y is 3n minus 1. Using your answer to part A or otherwise, work out the nth term of sequence z. How does it relate? Oh. If you times these two together, you get that. That's equals, not 11. 7 times 2 is 14, 9 times 5 is 45, 11 times 8 is 88. So all I have to do is do 2n plus 5 times 3n minus 1. And then just expand the brackets. I don't know why I needed all that space. I guess it's because it says, you know, using your answer to part A or otherwise. So if you did it like the otherwise way, then obviously, yeah. Okay, here is a sketch of this. Work out the coordinates of P. So that's basically the y-intercept. So I know that, alright, so it intersects at minus 1 and 7 over 2. Doesn't look like it on the way they've labelled it. So I know that x plus 1 is going to be a factor, and x minus 7 over 2 is going to be a factor. So I can just expand the brackets. And I can just see straight from that the, well, how did I get a negative? Oh, because this is an upside down quadratic. So actually y is going to equal the negative version of this. Oh, and also they've told us that it's been stretched by 2 as well. So I need to put a 2 in the front there. So let's put a negative 2 in there. So y equals minus 2x squared. What's that and that? That's minus 3.5 plus 1 is minus 2.5, which is minus 5 over 2. So that's going to be plus 5x. And then that's going to be plus 7. So the y-intercept is going to be 0, 7. Okay, that's going to be the end of part 1. I'll see you a little bit later today for part 2. Bye!